In this video, we're looking at the transformation called reflections. And to illustrate what reflections look like, we're going to use a square root function. Now, I've made a little t-chart here, a little input-output table for filling in this function. So whatever x is, we're going to take the square root of it. Now, when we start at -2, the problem is we can't take the square root of a negative number. And so it's not 0, it's literally blank. There is no output when x is -2. There's still no output when x is -1. We can't take the square root of -1 in the real number system. We can, however, take the square root of 0. What number times itself is 0? And that's 0. And that gives us a point right here. The square root of 1 is 1. Now, the square root of 2 is an irrational number. It's not nice and neat. It's 1.4 something, something, something. Square root of 3 is also an irrational number, 1.7 something, something, something. But the square root of 4 is 2. So some of these values are going to be nice and neat. And square root of 2, square root of 3, those have values, but they're very hard to plot. So are square root of 5, square root of 6, square root of 7, square root of 8. Square root of 9, though, is 3. So I'm going to plot these nice, neat values. So 0, 0, 1, 1, 4, 2, and then, let's see, 1, 2, 3, 4, 5 more would take us to 9. And this graph, oops, let's undo that mess I just did. This graph would look something like this, and it would go off in that direction. Now, there's nothing left of the y-axis because those are negative x values, and this can't use negative x values. So when we talk about reflections, it's a very simple little thing. And so I'm going to add another column to this. When we start talking about reflections, all we're talking about is throwing a negative in there. Negative times the square root of x. Now what this does is it takes the values we do have, which there's nothing there and there's nothing there. It slaps a negative sign on that output. So the negative of 0 is still 0 because 0 is not positive or negative. But when we look at this, we have the square root of x right here. We're simply going to apply that negative sign to the square root of x. So the square root of x when x is 1 is 1, but we're going to put a negative sign on it. Similarly, the square root of 4 is 2, so negative square root of x would be -2. Likewise, the square root of 9 is 3, so negative square root of 9 is -3. So simply putting a negative sign outside that square root changes things up. When you have an x value of 1, the output is then going to be -1. Right there. When you have a square root of, x value of 4, negative square root of 4 is -2. And similarly, we get -3 right there. And what we see is that this is a perfect reflection over the x-axis. So when we put a negative sign outside, so we have f of x equals negative square root of x, it makes a perfect mirror image over that y-axis. Now, we can also, so this gave us this reflection over the x-axis. We can also create a reflection over the y-axis. So I'm going to add one more table, or one more column on this table, and we're going to do this right here. What happens when you put that negative sign inside the square root? Now, we cannot take the square root of a negative number. So if x equals 1, so if x equals 1 right here, this would turn out to be this. It'd turn out to be the square root of -1. And we can't do that. And we can't do the square root of the negative of 4, because that'd be the square root of -4, which is not a real number. But what we can do is this right here. The square root of -1, because there's a double negative right there, and this then becomes just the square root of 1. So when we start looking at negative x values, We plug in negative x values, these up here. It works with this negative sign on the inside and actually makes them positive. And so what that means is when you have an x value of -1, we now have an output of +1. So that's still 0 because -0 is 0 and the square root of 0 is 0. But now we actually go into the negative values, and I'm going to add them down here, but -4 and -9, just to give us a few more values. The square root of -4, that would be the negative of the square root of the negative of -4, which would then be +2. And the square root of -9 would be +3. So when my x values are -1, I have an output of 1. When my x value is -4, I have an x value of 2. And then I have 1, 2, 3, 4, 5 right there. So when you put that negative on the inside, I didn't trace that very well, but it gives you a mirror image over the y-axis. So when I have f of x equals the square root of -x, we have a reflection over the y-axis. Reflection over the y-axis, reflection over the x-axis. Now, let's talk about these things in tandem. So this is our original function, and I'll write it in blue just to add a little bit of clarity, square root of x. We then talked about a reflection over the x-axis, which was negative square root of x, that flipped it down. And then we talked about a reflection over the y-axis, square root of -x. But it is actually distinctly possible to have this, which is negative square root of -x. What this does is it puts us over here, so quadrant 1, 2, 3, and 4. It puts us in quadrant 3, although I should move this 3 because we're about to draw there. 3. It would flip this one right here. It would flip it over the x-axis. It is possible to have a reflection over the y-axis and then again over the x-axis. And so you can have both simultaneously. And what you have is a lot of reflections. So you can have reflection over the y-axis, a reflection over the x-axis, and a reflection over both axes, as in the case of this green one.